So for today, we'll be doing some problems related to lecture 1.3. So this is partial derivatives and higher order derivatives. So I assume that you have watched the corresponding lecture video and have at least got an idea on how to do the topics, partial derivatives, and how to get higher order derivatives. So let's start with this problem. If z is a differentiable function of x and y related by z to the power x equals 4xy cubed minus z, then find the partial derivative of z with respect to x and the partial derivative of z with respect to y at x comma y equals 1 comma 2. Okay, so first, look at this. We are assuming that z is already differentiable. So because of this, maybe we can use the techniques that we already know. We just extend what we know in getting derivatives of functions in one variables. Okay, since remember, when getting partial derivatives of some functions involving several variables, with respect to one of the variables, what we do is we treat all other variables as constant. So it's like the function will only have one variable, so we can easily get the partial derivatives or the derivative with respect to that variable. So let's start with this. We have the point x comma y, and we have these three variables here where z depends on x and y. So let's find the value of z when x comma y equals 1 comma 2. So let's start with that. If x comma y equals 1 comma 2, then we will have z to the power 1. This is equal to 4 times 1 times 2 cubed minus z. So this means we have z to the power 1, it's just z. So we will have 2z. This is equal to 4 times 2 cubed. This is equal to 32. Which means that our z equals 16. So let's take note of that value of z when x equals 1 and y equals 2. Now, let's go and find the partial derivatives of z with respect to x and with respect to y. So let's start with finding the partial derivative of z with respect to x. So in this case, we take y as constant. So we treat it as constant. Now, we have this equation here, okay, or relation here. We have z to the x equals 4xy cubed minus z. So we have the function z. And since we are differentiating with respect to x, we have exponent here of the function z as a variable. So remember, if you have variable raised to a variable, we have some special techniques on how to get the derivative of that. Okay, so what we're going to do for this part, okay, we write the equation as x ln of z, and this is equal to ln of 4xy cubed minus z. And therefore, in this form, this is just function times function, or variable times variable. So if we find the partial derivative of z with respect to x, implicitly, okay, then the solution will be easier. We'll just have to apply a product rule and derivatives of ln. So from here, if we now start differentiating with respect to x, then for this guy here, we will have x times the derivative of ln of z with respect to x. Okay, so here we will have 1 over z times partial of z with respect to x, partial derivative of z with respect to x. That's left derivative of right, plus we have right, which is just ln of z, and then the derivative of x with respect to x. And that's just 1. So this is the left-hand side. For the right-hand side, differentiating with respect to x, so we will have 1 over something. That something, it's the 1 inside this parenthesis. So we will have here 4xy cubed minus z. And then by chain rule, we get derivative. We get the derivative of this guy here with respect to x. So we will just have 4y cubed minus partial derivative of z with respect to x. And then from here, we can just isolate partial derivative of z with respect to x. Okay. And then you may start substituting x equals 1, y equals 2, z equals 16. So you can do that. Okay. But in here, what my next line will be evaluation. So in here, when the point x comma y equals 1 comma 2, we will have z equals 16 according to this computation here. Okay. And therefore, we will have 1 over 16 partial of z with respect to x plus ln of z. So that's just ln of 16. And then this is equal to 4 times 2 cubed minus partial of z with respect to x all over 4 times 1 times 2 cubed minus 16. And then let's just simplify the right-hand side here. 4 times 2 cubed, that's 32. So we will have here 32 minus partial of z with respect to x all over, and then the denominator, it will become 32 minus 16. Okay? And then from here, 32 minus 16, that's just 16. So we multiply everything by 16. This will give us partial of z with respect to x plus 16 ln of 16. This is equal to 32 minus partial of z with respect to x. And if we isolate partial of z with respect to x, this will give us twice partial of z with respect to x equals 32 minus 16 ln of 16. And finally, partial of z with respect to x. So we divide everything by 2. We'll just have 16 minus 8 ln of 16. Okay? Any questions or corrections? Now, let us proceed with partial of z with respect to y. So for this guy here, we will treat x as constant. Okay, we'll just treat x as constant. So we differentiate with respect to z, and then therefore we treat x as constant. Therefore, this guy here, it's just a power, it's just z raised to some constant power. So we can just use power rule there when we start differentiating with respect to y. So we will have x z raised to x minus 1. By chain rule, we multiply this by the derivative of z with respect to y. On the right-hand side, we have 4x, and then the derivative of y cubed. That's 3y squared. So we will have 12xy squared minus, same here, you have partial of z with respect to y. Okay? And now, when we have x comma y equals 1 comma 2, we will get, so x equals 1 times, of course, z equals 16. So we will have 16. And then the exponent, it's just 1 minus 1. Then here we will have partial z with respect to y. The other side, we will have 12 times 1 times 2 squared minus partial z with respect to y. And then 16 raised to 0, that's just 1. And then we bring this to this side. We'll then get twice partial of z with respect to y. This is equal to 12 times 4. And this is equal to 48. Or we have partial of z with respect to y. This is equal to 24. So this is the partial derivative of z with respect to y at the point 1, comma 2. So any questions on this part? Okay, so let's go to our next problem here. Now, if z is a function of x and y implicitly defined by y cubed tangent of xz equals z squared minus e to the xy, similar problem, find the partial derivative of z with respect to x and the partial derivative of z with respect to y at the point 0 to -1. So you just need to make sure that this is true. This guy here, okay, satisfies this equation. When x equals 0, so this will become tangent 0. So left-hand side, we have tangent, we have tangent 0. That's 0. Left-hand side will be 0. And then here, z squared, -1 squared, that's +1. And then, yeah, we have here e to the 0, and that's 1. So 1 minus 1, that's 0. So this point here satisfies this equation. Okay? So we can have partial derivatives. Okay? So same process as in before. We have here, we start with partial z with respect to x. So it means we treat y as constant. Okay? So therefore, what do we get? We will have y cubed times derivative of tangent xz. That will be secant squared x z. But since we are differentiating z with respect to x and z are both variables, okay? And therefore, we need to apply, when we apply chain rule, we have to do product rule for this guy here. So product rule, we have x times partial z with respect to x plus derivative of x with respect to x, that's just 1. So this is just plus z. So this is the left-hand side. For the right-hand side, power rule, we just have 2z. Then by chain rule, multiply by the partial derivative of z with respect to x. And then for this guy here, differentiating with respect to x, we are treating y as constant. We'll just have y e to the x y. Then let's start. Let's evaluate at this point here. So here we will have, let me just write that. When we have x, y, z equals 0 to -1, we will have 2 cube secant of 0 times -1. So I'll just write secant 0. And then quantity, we have here 0 times partial z with respect to x. And then we have plus z, so plus -1. On the other side, we will have 2 times -1 times partial z with respect to x. Okay? And then minus, we have here 2, and then times e to the 0. Therefore, what will we get? If we simplify this, secant 0, that's just 1. 2 to the 3, that's 8 times -1. We'll just have -8. So this guy here, it's 0. And then on the other side, we have -2, -2 partial z with respect to x minus 2. So this implies that we have -2 partial z with respect to x. This is equal to -8 plus 2. This is -6. This means that partial z with respect to x, this is equal to 3. Okay? Easy. Now, let's do partial z with respect to y. So we have partial z with respect to y. So in here, we have this guy here. This is a variable, and then we have the tangent here. So we apply product rule for this. So differentiating with respect to y, left derivative of right. Let's start with that, which means we will have y cubed times the derivative of right, that's secant squared x z. And then by chain rule, since x is constant, we'll just have that x. And then derivative of z with respect to y. So that's left derivative of right plus right derivative of left. Sorry, that's right derivative of left. It's left derivative of right. And now we will have right derivative of left. So we will have 3y squared tangent x z. On the other side, we will have 2z partial z with respect to y. And then minus, here we have y. Since we are differentiating with respect to y, it is x that is the constant. So we will have here x e to the x y. Okay? So when x, y, z equals 0 to -1, so what do we get? We will have here 2 cubed, then secant squared of again 0 times 0 partial z with respect to y, so it will disappear, plus we have here 3 2 squared tangent of 0 will also disappear. This is equal to 2 times -1 partial z with respect to y minus, this is 0, e to the 0. So this implies that partial z with respect to y, this is equal to 0. Okay? Questions? Thank you. Let's have this third problem. Find and evaluate all first partial derivatives of f x, y, z given by this function at the point 1, -1, 3. So here, the function f, it's explicitly given in this form. So it means that we have 3 independent variables. So x, y, z are all independent variables. So our goal, well, it's to find f sub x, and then f sub y, and then f sub z. So all first partial derivatives. And then we evaluate at the point 1, -1, 3. So let's start with f sub x. So f sub x, it's the partial derivative with respect to x. So in this, here we have constant. Yz will be treated as constant. So it's just some constant divided by this guy here. And this is your variable x. So what will that be? So you have negative y z divided by x plus y plus z raised to power 2. Hello? Plus derivative of arctan, since we have x inside arctan here. So we need to get the derivative of arctan. Derivative of arctan, it's 1 over 1 plus the argument, it's x over y quantity squared times derivative of x over y with respect to x. So times 1 over y. So you can write the final expression in this form. Now, f sub x evaluated at 1, -1, 3. This will be equal to negative of -1 times 3 divided by 1 plus -1 plus 3 quantity squared plus 1 over 1 plus 1 over negative 1 squared times 1 over negative 1. So if we simplify this, we will have the numerator, this is just 3. On the denominator, 1 and negative 1, they cancel each other. So you have 3 squared. So for the first addend, we'll just have 1/3. Then for the second addend, so we have here negative 1. And then here, this is just 1. This guy here, it's just 1. So 1 plus 1 on the denominator. So this is minus 1 over 2. And therefore, this is simply negative 1 over 6. So negative 1 over 6. So this is the evaluated value of the partial derivative of f with respect to x. Next, we have f sub y. For this, we have y in the numerator, also y on the denominator. Okay? So we will have, okay, so there was a question and I want to point that out. So, sir, di po ba magiging negative yz, 1 plus y plus z yung numerator? Why is it that? Y and z, they are constants. So the derivative of that with respect to x, there will be 0. So times 1 only. Correct? That is correct, that you need to apply chain rule. So you have this, you will get this guy here, and then by chain rule, you need to get the derivative of this. Correct? The derivative of x with respect to x, it's 1. But for y and for z, the derivatives with respect to x, they are both 0. Because again, they are independent variables. So we treat y and z as constants. Okay? That's a good question. So I hope that cleared the confusion. All right. So f sub y, we have y in the numerator, y on the denominator. So we apply quotient rule for that. So let's do that. We have low x plus y plus z times the derivative of high, derivative of yz with respect to y. So times z minus high, which is yz, times the derivative of low. That's just 1. Because again, derivatives of x and z with respect to y, they are both zeros. And then we have the low here, x plus y plus z squared. Plus in here, we need this because the argument here, it has y. Okay? So we need to get the derivative of tangent inverse. Just like before, we will have 1 over 1 plus x over y, quantity squared, times by chain rule, we need to get the derivative of x over y with respect to y this time. So if you do that, x is treated as constant. It will become, the derivative of x over y will be negative x over y squared. Okay? And then we evaluate. Let's have f sub y, 1, negative 1, 3. So in here, we have here 1 plus negative 1 plus 3 times 3 minus negative 1 times 3 divided by 1 plus negative 1 plus 3 quantity squared. Then here we will have plus 1 over 1 plus 1 over negative 1 squared times negative 1 over negative 1 squared. And then let's just simplify this fraction here. So this guy will cancel this. So it's just 3 times 3 here. We'll have 9. And then here we'll have plus 3. Denominator, it's just 3 squared. And then for the other guy there, we will have minus. It's minus because this guy here, it's still negative. Okay? And then this guy, it's 1/2. So we have minus 1/2. So simplifying, we have 12 over 9 minus 1/2. 12 over 9, that's 4 over 3. 4 over 3 minus 1/2. And this is equal to what? 8 minus 3. So that's 5 over 6. This is 5 over 6. Okay? Questions? Next, f sub z. So partial derivative of f with respect to z. So in this function, we have z in the numerator, we have z on the denominator. So we apply quotient rule again. So we have here low, so x plus y plus z times derivative of phi with respect to z, so times y, minus high, which is yz, times derivative of low with respect to z, that's just 1 again, denominator squared. So x plus y plus z quantity squared. Now, this guy here doesn't have a z. So basically, with respect to z, this is just constant. Therefore, derivative of that will just be 0. Okay? So in here, what's left to do is to evaluate 1, negative 1, 3. So it's like before, we have 1 plus negative 1 plus 3. Y, it's negative 1. Then minus negative 1 times 3. Denominator, we have 1 plus negative 1 plus 3 quantity squared. So if we simplify this, we will have, so 3 times negative 1, that's negative 3. And then this becomes plus 3. Over denominator, it's just 3 squared, but this is equal to 0. questions? For the final problem of our session for today, so we have the function f of xy equals e to the 2x cosine 3y. So we want to show that this function satisfies this differential equation. So all we need to do is, well, we have the function f, substitute it there. We need to get f sub yx. We need to get f sub xx. We need to get f sub y. Okay? So let's start with f sub y. So partial derivative of f with respect to y. So f of xy, we get the partial derivative with respect to y. So e to the 2x, this is just constant. So derivative of cosine 3y, what's the derivative? We will get, is that negative sign? So here we will have e to the 2x, and then we have negative sine 3y. By chain rule, multiply by 3. So we have the 3 here. And then let's continue with the partial derivative with respect to x coming from here. So it means we will be able to get this. So we will have f sub y sub x, f sub y x. So we need to get the partial derivative of this with respect to x. So with respect to x, this is just negative 6 e to the 2x sine 3y. Now, we need f sub xx. So we start with f sub x, xy. So derivative with respect to x, this is just 2 e to the 2x cosine 3y. And then, with respect to x again, so we have f sub xx, x comma y. This will just be 4 e to the 2x cosine 3y. So finally, let's have 4f plus f sub yx. So we will have here 4 times e to the 2x cosine 3y plus f sub yx. We will have negative 6 e to the 2x and then sine 3y. So this is the left-hand side. For the right-hand side, we have f sub xx plus 2f sub y. F sub xx, that's 4 e to the 2x cosine 3y. And then plus 2 times f sub y, that's negative 3 e to the 2x sine 3y. Indeed, if we simplify this, these two guys here are the same. 2 times negative 3, that's negative 6 in here. So this implies that 4f plus yx, f sub yx, this is equal to f sub xx plus 2f sub y. So this means that this guy here is satisfied or holds.